Hi, it's me again, back for the third in a series of short videos on how refracs can help make America's old oil and gas wells great again. Last week we talked about getting the right team in place, making sure you got the right players on board, make sure that the disciplines are integrated and everybody's on the same page, and how that can help reduce refrac risk by itself. This week we're going to talk a little bit about determining the size of the prize. What's there? What's the target? What's the remaining oil and gas that's accessible? And next week we'll talk about looking into why it's there, some of the mechanical properties issues, what the first frac did, and mainly just to make sure you don't repeat this problem, but then also to explain why it's there. And then the last week we'll talk about putting it all together and executing an optimized refrac program to get the oil and gas out of the ground economically. And that's the key thing, is economically and consistently. Determining the size of the prize requires fairly detailed petrophysical work. Sometimes the detail is not commonly done. We like to start with a core calibrated model. Make sure you've got the good agreement with core on porosity. Shale volume is very critical. Accounting for the amount of kerogen in the resource plays is critical. There's a lot of ways to do that. Some good and some not so good. We like to think what we do seems to work. And you can validate that with production. Your EUR should be, representative of what the oil in place is. I mean, you should be able to come up with a reasonable recovery factor, and these recovery factors typically repeat pretty well within it's not a less than 1% range. It's maybe plus or minus 10%, but still, I mean, you're getting a reality check with the actual production coming out of the ground, which a lot of times you don't see that. And a lot of times you don't see that because people don't know what's producing. Because you have to understand what the frac's doing to give you that, and how it interacts with the rocks, and how you have the role of prop conductivity, unprop conductivity, things like that, and, brittleness, rock brittleness. All that goes into that. It's not a simple just process of just estimating the porosity and water saturation and net feet of pay. That's one thing, but you got to also know what's producing. Conventional reservoirs are a little more straightforward in that respect. Usually the pay is going to be producing. You don't have to worry about height. But the resource plays particularly are important in that you've got really a lot of H, and small changes in porosity and saturation can affect your oil in place and gas in place quite a bit. So you have to basically deal with that and make sure it's normalized to start with. A lot of companies don't normalize. We recommend that strongly. A lot of companies don't compare back to production. We recommend that strongly. And a lot of companies use models that tend to try and estimate the amount of each mineral in there. And by and large, in the past, one log can give you one mineral. Yet you see people coming out with 7 and 8 minerals and kerogen volumes and things like that. From TOC, which TOC is in gas wells is kerogen, but not so much in oil-rich wells. TOC is mobile fluid and kerogen. So if you're treating it as all kerogen, it's not going to be right. The key is to get a good model and then put it all together with the geological characterization. You're only measuring 8 inches of borehole, so you want to make sure that you're extrapolating this. Sometimes you'll have one well every mile or so. So you're taking an 8-inch measurement and extrapolating that. So the mapping part's fairly important, particularly in larger fields. And we did a lot of that at the BEG when I was there. I did a lot of integrated reservoir characterization studies, and we've used that template over and over again on dozens of projects where we go in and basically determine the reservoir architecture first, determine the fluid flow characteristics, what's the properties, what's your porosity, map your porosity, map your saturations, map your thickness. Don't map the oil in place. That's really has no geological significance. It's you have to look at the individual parameters or go into it. Little things like that we like to do, and then put it all together. The volumetric equations are fairly straightforward. Get a good formation volume factor for oil, because that's a function of GOR, gravity, and pressure and temperature. That can affect your output quite a bit. But come up with a credible model that's tied back to reality, and then work it. Then you've got a target. And then the next phase, or really the final phase, after you put it all together, and the program that you put together is basically see if it's economical. Does the cost of the refrac program recover the oil in place effectively? And that's important. And that's the last step we'll talk about in the subsequent videos. But to start with, you got to get a good idea what the size of the prize is, and that's what we talked about today. So Next week we'll talk about the mechanical reasons why it's still there, why is the oil and gas still there, and final week we'll talk about the recommended best practices for it. And for that, that's all for this week. Thanks for your time.